We are now recording, finally, from current slide. From current slide. Here we go. All right, chapter 6, continuing from what we did in chapter 3, is quadratic equations and inequality. Now, we did more than quadratic equations. We did some higher order and lower order, but we definitely did a bunch of quadratic equations, and this just builds on it, okay? And 6.2, that's the title, quadratic equations. What we'll be doing is solving quadratic equations by factoring exactly what we were doing in 3.6 and 3.7. We will solve quadratic equations in a different way from what we've done before. So this is a new technique. And then we'll solve problems pertaining to right triangles and the 30, 60, 90 triangles, which we did right at the end of 3.6 and 3.7 as well, Pythagorean theorem. Okay? So this builds on what we were just doing. Now, of course, a quadratic equation is a second degree equation. That means the maximum exponent is 2. Okay? In one variable, and contains that variable with an exponent of 2. So they're being a little redundant here. But no higher power. Okay? And no fractional powers, no decimal powers. You have power, the variable can have an exponent of 2, 1, or 0. That's the only choices for a second degree equation, also called quadratic equations. Is that a quadratic equation? X squared equals 36. Sure it is. Maximum exponent is 2. How about this one? Y squared plus 4y is equal to 0. Yes, for sure. How about this one? X squared plus 5x minus 2. Yes. Now, if we were to solve this, the best idea is to subtract 36 from both sides and then factor it. This one, definitely factor, greatest common factor. This one, you can try to factor all day long. You'll never get that to factor. And in the 2 sections from now, we will figure out a way to do that. Okay? So, a quadratic equation in the variable x can also be defined as any equation that can be written in this form. Now, we're going to start calling this, in fact, right here, the standard form for a quadratic equation. Okay? Now, next course you take, if you go into Math 112, you'll learn that this is not quite the same as the standard form for a quadratic function. But don't worry about that. We'll get there later. Okay? Name, please? CJ, I thought so. There you are. Okay, was there a question, comment? Okay. All right, but this is what we're going to call standard form for a quadratic equation. Guess what? We've already been using it. When do we use that? Second? Okay, yes, when we factor, but name, please. Second? Sheffield, got it. J, right? Yeah. Okay. All right. Anyone else come in since the call wrong? Okay, but more specifically, the AC method, we use this form precisely. Name, please. Brianna, got it. Thank you. Okay. All right. Anyone else come in since the call wrong? All right. Now, in this standard form, the A, the B, and the C are any real numbers in the world, real numbers, with one exception. A cannot be 0. Now, why could A not be 0? It can be positive, it can be negative. It can be a fraction, it can be a decimal. It can be rational, it can be irrational. Any real number except 0. Why not 0? If A were 0, that wouldn't be a quadratic equation, would it? Because this first term wouldn't exist. 0 times x squared would be 0. You'd have bx plus c equals 0. That would be a linear equation with credit to that, but that's the reason A can't be 0. It would be an equation, it just wouldn't be quadratic anymore. And that's called the standard form of a quadratic equation. We'll solve quadratic equations of the term, but we didn't use the term quadratic, they said. I think we've been calling it that all along. By factoring, yes, that's what we did in the chapter 3. And by applying the property AB equals 0 if and only if A is equal 0 or B is equal 0. All the time we were doing that. And we'll continue to do that, okay? So let's do one. Again, this is a review of what we already have done, but maybe a little more involved. How would you approach a problem like that? Got to get my pen. There we go. I think I got it. How would you try it? We know of at least 2 techniques you could use. AC, you want to use AC method? All right, what's your A? What's your C? Negative 5. And I wrote A and when I said C, okay? Okay? C is equal to negative 5. So what is AC? Negative 15. Okay, that means you're looking for 2 factors of negative 15. And of course, since it's negative, one has to be positive, one has to be negative. Who's going to be the bigger one? The 15's got to be, well, okay. The larger one has to be the positive, okay? And the reason for that is the middle term is positive. So, we're going to start with that. I didn't ask, what is B? 14, okay? So B is equal to 14. Now what the deal is, we need 2 numbers that multiply to be negative 15 and add to be 14, with the larger number, larger value being positive. So we'll start with our minus. What's the first factor of 15? 1. And second factor? 15. That certainly multiplies to be minus 15. And what does it add to? 14. Ding, ding, ding. We got a winner right off the top. What do we do with that? Okay, we split that middle term into minus 1n plus 15n. So this will be 3n squared. We don't mess with that at all. Okay, and this will do minus n plus 15n. That adds to 14n, right? Minus 5 equals 0. Okay, what do we do next? Group. Okay, is a 1 there. I didn't mean to write on top of it. Okay, what do we do with the first group? Factor. How does it factor? Pull out an n. What do you have left? 3n minus what? 1. And in the second group, what do we do? Pull out a 5. And what do we have left? 3n minus 1 equals 0. Now what do we have? A common binomial factor. And we pull out an n plus 5 and a 3n minus 1. Okay? Equals 0. That should be the correct factorization for that. Let's just see if it works. N times 3n is 3n squared. Minus n plus 15n plus 14n and minus 5. Yes, for sure it works. Okay? Now, what do we do now? It says solve it. Have we solved it yet? No, all we did was factor it. What do we do now? Set each of them equal to 0. So the first one would be n plus 5 equals 0, or 3n minus 1 equals 0. The only way you can have 2 things multiplied together giving you 0 is one or the other of them has to be 0. And what do we do with the first one? Subtract 5 from both sides, and that gives us n is equal to -5, or what do we do with the second one? Help me, help me. Say again? I can't hear. Add 1 to both sides. Excellent. Okay, and that gives us 3n is equal to 1, and then what? Divide by 3. And that gives us n is equal to 1/3. So there are two solutions, and since it's a quadratic equation, that means maximum exponent of 2, you can have no more than 2 solutions. You may have only had 1, you may have had no solutions, but you can't have more than 2. We found 2, quit looking. Okay? And it's not too bad to check this. If you plug in a -5 here, what's -5 squared? -5 squared. 25 times 3. 75. This sounds like some big numbers to me, so I'm going to write them down. So the first will be 75, okay? And it's going to be plus 14 times a -5. Anyone do that in your head? What's that? -70, okay? So, yeah, this isn't going to be too bad. -70 and -5, does that add to 0? Sure it does, okay? The next one, I think it'll still be okay. Let's plug in 1/3. What's 1/3 squared? What? Say again? 1/3 squared, that means 1/3 times 1/3. What's that? 1/9, okay? So that would be, I'll write it over here, 3 times 1/9 plus 14 times 1/3 minus 5. Is that equal to 0? Who knows? All right. What can you do with the 3 and the 9? Second? Yeah, 3 will go into 9 3 times. So that leaves us a 1/3 here, plus, and 14 times 1/3 is 14/3, minus, now, these are in thirds. How many thirds is 5? How many thirds is 5? Okay, if we had, I think in terms of food, if we had 5 pieces here, okay, and I cut each of them into thirds, so how many pieces of pizza would I have? 15. So it's 15 thirds, right? Think in terms of food. It makes fractions much more fun anyway, okay? Minus 15 thirds, and 15 thirds is 5, right? 3 will go to 15 5 times. Is that equal to 0? What's 1/3 plus 14 thirds? 15 thirds minus 15 thirds? Sure enough, that is 0. Okay, you don't have to check a problem, but man, why not, okay? Because I like to get right answers, and I always like to check to see. Now, I just noticed in the new text, this isn't a new text. No, yeah, it is. This is one edition newer than the slideshow is, okay? I noticed at the bottom of page 303, if we go back a slide to here, they have a few more equations there that they didn't put on the slide. Don't know why, but let's do it. Okay? 3n squared plus 2n minus 1 equals 0. Is that a quadratic equation? Sure. The maximum exponent is 2, and there's no fractional or negative exponent, so yeah, you're fine. How about this one? Well, this is a strange looking one. 5x squared plus x plus 2 is equal to 3x squared minus 2x minus 1. Is that a quadratic equation? Sure, the maximum exponent is still 2. Now, what would you have to do to try to solve that equation? Not a lot, a little work, but it makes a big difference, okay? What would you do? Yeah, get them all on one side and the other side equal to 0, because we want it in our standard form like this and that. Not like this, but like any of the others, okay? So you would subtract 3x squared from here, add 2x to there, and add 1 to there, and then this side is equal to 0, and you have standard form. So yes, that's still a quadratic equation. Now, if one of these had been a 3 rather than a 2, not a quadratic equation anymore. Okay? So, I just noticed they had some there they didn't have on the slide. So let's move on to see how they solved this problem. How they solved it. Man, this thing is so slow today. Okay. So, how did they do it? They didn't do it. Oh, there it comes, okay? It was really slow. They wrote it again. What a good start, okay? Then they factored it. They didn't use AC method. They factored trial and error. And if we were doing trial and error, I would have said, well, there are only two factorizations, 3n squared, 3n times n. That would have been fine. Then we would look at the sign of the last term, negative. That means these two signs have to be different. That's fine. And then we looked at this to see what's the only factorization of 5. It'd be either 1 and 5 or 5 and 1. So we would have had maybe a little bit of trial and error there, but not too much. They got the same thing we did, and then they split it into using the zero product principle, 3n minus 1 equals 0, or n plus 5 is equal to 0. Solving that, 3n is equal to 1, or n is equal to negative 5, and over here, n is equal to 1/3, and n is still equal to negative 5. So that gives that as your solution. Okay, can I get your name, please? Chris, got it. Okay, I got two Chris's, so let me get the right one. There you go. All right. Good deal. Okay, I don't require you to write it as a solution set, but the back of the book will usually list the answers in the solution set, so be sure you understand what's going on there. Any questions on example 1? Okay, so they decided to just skip example 2 since you didn't have any questions. Not a good choice, okay, because example 2 is a lot different kind of problem. So let's take a look at example 2. Solve this. 2 times the square root of x is equal to x minus 8. Where in the world did they come up with that? Okay? It doesn't matter where, but we'll deal with it. Now, does that even look like a quadratic equation? Really? Okay. What's the exponent of this thing? If you wrote it a slightly different way, now I'm not sure you have done this at all, and certainly not recently, but does anyone know that? Okay, not x squared, x to the 1/2. A square root is x to the 1/2. I don't think you have that. We'll cover that in the next chapter we do. So, but we skipped over from 3 to 6, so that's why we're missing this. But let me give you a heads up now. We don't like radicals in an equation if we can help it. So how do we undo a radical? What is a square root anyway? What does it undo? It's in the name. That's a perfect square. So how we undo a square root is to square it. Warning, warning, warning. Anytime you square both sides of an equation, which is the next step we're going to do, that means you have to check your answers. We've been checking your answers just because I like to. I want to make sure I have it right. But when you have something like this, you've got to check the answers because you may have introduced what they call an extraneous solution. something that looks like it's correct but really isn't. So the first thing we're going to do is, well, what we typically do is isolate the radical. Now, we could divide by 2, but then that introduces fractions. I know y'all love your fractions, but I just don't care for them that much, okay? So I don't want to divide by 2 because that would be okay, but this would be a 1/2. So let's just square the whole term. You've isolated the term with the square root in it, so square that term. So what happens if we square both sides of this equation? So we're going to square this and also square that. So tell me what you get here. Square 2 and what do you get? 4. Square root of x and you get what? X. Very good. Equal square x minus 8. Anyone know what that is? Help me. Say again? Anyone know? X squared, did I hear that? Okay, x squared, I'll buy that one. A little louder. Okay, I know there's a plus 64 there, but we're missing something. The inner term. Say again? Ah, very good. Only not plus. Did you say plus? It's minus 16x. Okay, here's the rule for squaring a binomial. Square the first term twice the product of the 2 terms. The product of the 2 terms is minus 8x. Double that and you get minus 16x. And then square the last term. Notice this is always positive, that's always positive. This will be whatever sign that is. Okay? Now, if you don't remember that rule, still pretty easy to do. What could you do? X minus 8 times x minus 8. That's what it means to square something. Multiply it by itself. That's what squaring does. Okay? And then here we have x times x is x squared. Then the outer would be minus 8x. Inner would be minus 8x. And the last would be plus 64. And you see, the first squared, the last squared, and twice the product of the 2, x squared minus 16x plus 64. So if you don't want to remember the little shortcut rule, follow it. You can always do that. Okay? Now what do we do? Yeah, I get the 4x on the other side because we want one side equal to 0, the side without the square in it. So let's subtract 4x from both sides. And I'm going to rearrange it and do x squared, what? These add to 0. What do these add to? Help me. Negative 20x plus 64 equals 0. Where do we go from here? Okay, we want to factor it. Which technique do you want to use? Trial and error or AC? I don't care too much. AC? Okay, let's try AC. What's your A? What's your C? 64. Maybe you said it. I couldn't hear it. I only heard a 4. Okay, sorry. And what's your B? Negative 20. All right. So we want two numbers that'll multiply to be what AC is. And what is AC? It's 1 times 64, which is 64. Okay, we want two numbers that multiply to be 64, but add to be negative 20. Okay, so what does that tell you about the signs of these two numbers? And both are negative because the product's positive, but the sum is negative. They both got to be, see, the product being positive tells you both have to have the same sign. Since the sum is negative, they've got to be negative. So it's going to be negative, negative. You want to start with the easiest ones? I mean, the smallest ones? Tell me what it is. Okay. Negative 4 and negative 16. Okay. That sure enough adds to minus 20. So that's good. And they multiply sure enough to be positive 64. So what do we do with that? Instead of negative 20. So x squared minus 4x minus 16x plus 64 is equal to 0. All right, where do we go from there? Group them, okay? We'll group these two and group those two. Now that looks like I'm multiplying them, I'm not. I'm just grouping them. What do we do with the first group? Factor out an x, and what do you have left? X minus 4. And in the second group, a what? Okay, only pull out the minus with it. Minus 16. And what does it leave you with? X minus 4. Very good. That's equal to 0. So what does this give us? X minus 16 times x minus 4 is equal to 0. And you can check that by following. You see you get the right answer. So what does this tell us? X equals 16 or x equals 4. Are we through? No, why not? We've got to check it because we squared both sides. Other times checking is a luxury, just to make sure you got it right. This time you've got to do it. So let's go back to the original form, not the squared form. So 2 times 16, wait, what's the square root of 16? 4. And 2 times 4 is what? 8. And what's 4 minus 8? Negative 4 squared is positive 16. Square negative is always positive. Hey, that didn't work, did it? That gave us 8 is not equal to 16. So this x equals 16 does not work. Let's try the other one. What's the square root of 4? 2. 2 times 2 is 4. Okay, got that. And 4 minus 8. Oh, wait. I was squaring that. Forget it. Okay. Let's go back to the 16. Sorry. When you're doing this, it's probably a good idea to take that part off. I said ignore it, and then I didn't ignore it. Okay. There was our original problem. Okay. Let's go back to the 16. In fact, let me erase the cross because we haven't verified that yet. Okay. All right. Let's go back and start again. I messed up. Okay. Square root of 16 is 4. And 2 times 4 is 8. And 16 minus 8 is 8. Okay, so that one is correct. Sorry about that. Okay, let's do the 4. Square root of 4 is 2. 2 times 2 is 4. And 4 minus 8 is negative 4. Is 4 equal to negative 4? Oh, if it is, I owe you $4, so give me $4. Okay? If I owe you negative amount and that's the same as positive amount, that means give me $4. Okay, no, that doesn't work. Okay? So this one is the one that doesn't work. You get a negative on one side, a positive on the other. That one doesn't work. So 16 is our only solution. You've got to check them anytime you square both sides. All right, moving on. Now, I'll try not to give you any with square roots in them. I can't remember if there are or not, but if you do, you know how to do them. We just did it, but that was something that we'll do later. So I've got to check the test bank and make sure there's none of those. So solving quadratic equations of the form x squared is equal to a. Okay? Now, we've already been doing some of these. Let's consider quadratic equations of form x squared equal a, where x is a variable, a is some real number, any real number. One way we could do that is to subtract a from both sides. You have x squared minus a equals 0. Now, if a were a perfect square, we know exactly what to do, right? X plus the square root of a times x minus the square root of a. Square root, sometimes the difference is square roots. But this still works, even if a is not a perfect square. You get x minus square root of a times x plus the square root of a. So this gives us, and when you set this equal to 0 and that equal to 0, you get x equals square root of a, or x equals minus the square root of a. Okay? Now, again, square roots are done in the chapter we skipped, so this is a little beyond what we've done. But look at here. Remember at the very beginning, when that was a perfect square, say x squared is equal to 4, someone would yell out and say, what's the answer? And you'd say, if x squared was equal to 4, what's the solution? X equal 2, right? Right? Not quite. It's plus or minus 2. Just like here, we get plus or minus the square root of a. So, what we're going to do now is, rather than going through this sort of convoluted way of doing it, let's just go back and do this. Here's a property. For any real number a, any real number, it doesn't have to be a perfect square. It doesn't even have to be a whole number. It could be pi thirds. Ooh, what kind of number is that? Irrational. But you can still do it. If x squared is equal to a, that's true if and only if x is equal to plus the square root of a or minus the square root of a. In other words, take the square root of both sides and remember always to do a plus or a minus. So we can write it like this. I like to write it like this because I'm lazy. But you could write it x equal positive square root of a or x equal negative square root of a. Okay? So, remember that when we had at the very beginning? X squared is equal to 36. I said the safest way is to subtract 36 from both sides and then factor. What's the other way we could have done? X equal square root of both sides. Okay. I don't know if you remember, it was there. It was x squared equal 36. So using this technique, what would it be? X equal, what'd you say? Except you put plus or minus 6. You got it. Plus or minus the square root of 36, which is plus 6 or minus 6. That way you get both the answers right. Otherwise, you only get one of them right and you miss one. Okay. So that is the new rule that we'll have now. Now that property 6.1, along with our knowledge of square roots, which we're going to learn more later, makes it easy, very easy to solve quadratic equations of that form. Rather than subtracting and then doing square roots and factoring, just take the square root of both sides, as long as you remember what? Plus or minus. The right-hand side, when you take the square root, is going to be plus or minus. Okay? So let's do this one. What's the answer? You can almost just write it down. Anybody? Help me, help me. X, I like that, is equal to plus or minus the square root of 45. That's all you have to do. Now, except to get the answer the book wants, and this again is because we're going back to chapter 4 in just a little while, but I'm going to give you a heads up on what to do with problems like this. Okay? Since this is a square root, we want to make sure we don't have any perfect squares hiding in there. So what we do, we factor that 45. Does it have any factors? Yeah. How can you factor 45? 9 times 5. Well, now you can rewrite this as plus or minus the square root of 9 times the square root of 5, right? And you know what the square root of 9 is? 3. So this will be plus or minus 3 times the square root of 5. You don't know what the square root of 5 is, so leave it alone. There's the answer the book is going to like. For right now, that answer is perfectly okay with me because we haven't done this. I'm showing you now, but you don't have to do it this way. The book always is going to do that one more step, okay? So I'm going to try to avoid those on the test too. I don't know if I'll succeed, but we'll try to. Let's watch how they do it, and I bet you it's awfully similar. Any questions on it before I erase it? Everybody got it written so far? Okay. So let's erase it and see. Ooh. So what they do is write it again. Good. First start, okay? Then they take the square root of both sides. That's x equal plus or minus square root of 45. As far as I'm concerned, for now not after we do chapter 4, but for now, that would be a perfectly fine answer. But they're going to take it one more step, and that's why they took it one more step, and do plus or minus 3 root 5. That's actually 2 solutions. You had a quadratic, you expect up to 2 solutions. There they are. One's positive 3 root 5, the other's negative 3 root 5. They're different numbers, because one's positive, one's negative. Okay. Now, the next one, example 4, in your text, is x squared is equal to negative 9. We're not going to do that, are we? Because when you square a number, it's always positive. There you're going to have to introduce that I we talked about in 6.1. I said it's not under the scope of the course, so we're going to skip those completely, okay? If we need them, I'll bring you back in. But let's just skip it for now. Example 4. Let's move back to example 5, okay? And here's example 5. 7n squared is equal to 12. Okay? What in the world can we do with that? What would you suggest?
You can leave that 7 right there, can't you?
What's that?
You can leave that 7 right there, can't you?
You can if you want to, but I sort of prefer to get that n by itself, the n squared by itself. Because if you remember the name of this section, quadratic forms of the form x squared is equal to a. Well, that's a 7n squared is equal to a, so therefore I want to get it just n squared. So how do we get rid of the 7? Divide it by on both sides. Okay, you don't get rid of it, you just move it around some. So you get n squared is equal to 12 over 7. Yay, what a pretty fraction that is. And now what do we do by the last rule? Take a square root. N is equal to, what goes with the square root? Plus or minus the square root of 12 over 7. Now for right now, where we are, that's a perfectly fine answer. Now when we do the next one, the summer, when we do the next section, next chapter, when we go back and do chapter 4, we're going to do a little bit more to this. Do you want to see that now or just forget about it? If you are trying to get the answers in the back, the answers in the back will do a little bit more. But you're not required to do those with fractions or square roots. We'll do those later. You want to know now or wait till we get there?
You show it now.
Show us now. Okay, we'll do it. Okay? Now, that's plus or minus. I'm going to rewrite this as the square root of 12 over the square root of 7. That's a legal move in most states. Okay? Now, let's deal each one of them separately. Remember what we did on that one? We looked to see if there's any perfect squares lurking or hiding in 12. Are there?
Yes.
Which one? 4. Okay. So we'll break that into plus or minus the square root of 4 times the square root of what? 3. Okay. Now, there's no perfect squares hiding in 7. Okay, at all. However, well, I'll go and write it down. The square root of 7. Okay. Now, I've sort of avoided saying this, but I'll say it to you now. There's 3 things when we have square roots. There's 3 things we look for. We've already seen one. We don't want any perfect squares hiding under a square root. We want to pull them out. Just like, ooh, I didn't quite do it yet. Like here. Plus or minus 2 root 3 over root 7. So that's one thing. Pull any perfect squares out. We've done it. We did it in that one. We did it in this one. Okay? But there's another thing. Actually, there's 2 things. We don't like radicals in the denominator, and we don't like denominators in the radical. Either one. Okay? Now, there's a reason for that, but it's an ancient reason. Not really that old, but it is a reason. All of you have grown up with calculators, right? Now you got phones that do all the calculations you ever need. But guess what? There was a time, not too long ago, when calculators didn't exist, okay? And when you did square roots, you either looked them up in the table or you did them by hand, okay? That was an ugly time, okay? But that's what we did. Now, and just to fill you in, none of you are old enough to remember this, I don't think, but when I was a sophomore in college was the first time I ever saw a calculator. I had heard about them maybe previous year or 2. I'd never seen one until my sophomore year in college. I was in a physics classroom. It was the beginning of my sophomore year, fall term, 8 o'clock in the morning, first class, and I was sitting in this huge lecture room with about 200 students in it, in a physics class, and here came 2 guys walking in, and they had these things back then. They strapped them to their belts, really nerdy, okay, and came in and walked, and the rest of us went, there goes the curve, okay, because these guys could punch in numbers and get answers. And those calculators would add, subtract, multiply, and divide. That's all, folks. And you had to plug them into a wall. They wouldn't work on a battery. And they cost $600. It was ridiculous, okay? But that was the future, and every year many improvements came, and soon they could do square roots. At the time they couldn't, but now they could. Before that, okay, and that wasn't that long ago, folks. Before that, everything was done by hand. And I want you to think of some pretty important things that have happened before that. Does anyone know what the Manhattan Project was? Anyone? Okay. That was when we developed the atomic bomb. It had never been done before. And if you think these may be difficult calculations, you don't know nothing yet, because to calculate, to do the calculations to develop an atomic bomb from scratch, from theory, took some heavy duty calculations. And what the government did, this was during World War II, what they did, they hired in roomfuls like this of the brightest, best mathematicians and physicists that they could find all through the country, from the universities and everywhere else, and they hired them to come in and solve problems, because they had to do them all by hand. And they'd have a whole room for it, solving the same problem, They gather up all the things and look at the answers. The one that came out most, they said, we hope that's the right one. Because these calculations were so hairy, they couldn't count on just one person. They did the brightest minds they could find, had them all, and then the one that came up most frequently, they said, we hope that's the right one. Because these were awful to do. I mean, those were much more awful than this. And here I want to suggest to you, if someone has a calculator, punch into it. I'm just going to do this. This isn't quite the same problem. It'll be a lot easier. 2 over root 7. Okay, this will be a little bit easier. Does anyone have a calculator and do the square root of 7? That'd be 2 divided by, what is the square root of 7? 2.7 or 8, something like that. Okay, give me. You got it? Okay. Calculators are so slow, aren't they? Okay. You can't get it? Has anyone got a calculator? Give me the square root of 8, square root of 7. Please, somebody. Square root of 7. Say again? No, that's 7 squared. The square root of 7. Oh my goodness. This is not doing well, folks. Say again? Say again? 2.5 what? Oh no, it can't be 3. Is it? Say again? 2.6. More digits, right? Well, maybe your phone doesn't, but calculator would. Say again? 2.64 what? Keep, slow down. 2.64 what? 5, 7, 1, 1. Say again? 7, 5, wait. 6, 4, 5. 7, 5, 1, 3. Is that right? Okay, is that it? 1, 1. Is that all? Say again? 0, 6. How big a calculator you have? 9, 1. Goodness gracious, I've never seen a calculator with that many digits. Okay? Now, what if we were doing that division? Okay? That division would be 2.64575131. Let's just stop there. Divided into 2.00000000. You know, a bunch of zeros. Then you'd have to move this. Remember how we did this by hand? Y'all don't remember this. You have to move it 1, 2, 3, 4, 5, 6, 7, 8, 9 places. 1, 2, 3, 4, 5, 6, 7, 8, 9 places. And then you start your division. And you got some work to do. Right? I'm not going to go there. Here's what mathematicians, I have this rule about being good in math. Okay? I've never seen this proven. This is just my opinion. I think to be really good in math, you need to be just a little bit lazy. Do any of you qualify? No? Okay, just a couple of them. The rest of you hard workers, you can still do it. But if you're a little lazy, you're always going to look for the simplest way to do a problem. And here's what mathematicians found out. Rather than doing this, they said, well, let's just do 2 over root 7 and then multiply the denominator by root 7 again. But if you do that, you have to multiply the numerator by root 7. Okay? And this will give you 2 root 7 over, and what's root 7 times root 7? No, root 49, which is 4, no, 7. when you square a square root, you undo it. That just gives you 7. Now I can multiply 2 times root 7. That will be 5.291502622. Okay? That wasn't hard to multiply. I stopped at that one. And then I can divide this by 7. And guess what? That's a lot easier division than this one. Way, 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 way easier. So back in the day, before there were calculators, before there were computers, when you were trying to divide, that's why they said no denominators in your radical and no radicals in your denominator. Because those are nasty, nasty, nasty to try to calculate. So what we do is say rationalize the denominator. So we'll do the same thing we did there, but do it here. Multiply the denominator by root 7. Multiply this denominator by the numerator by root 7, and this gives you 2 times the square root of 21 over 7. Now, again, you don't need to do this yet. When we get to the next chapter, yeah, you'll do it. This answer would be perfectly fine for me. But this will be, not that, plus or minus. Okay, so that's how you get the answer they do in the book. Okay, and I'm sorry I took that much time for it, but you'll see that's their answer. Plus or minus 2 root 21 over 7. But don't sweat that now. I'll try not to give you any of those on the test yet. When we get to the next chapter, you'll need to do that, but not yet. Okay. Let's do example 6. That's going to be a lot more fun. Okay. So let's clear the ink on this slide. And let's do example 6. Solve this. 3n plus 1 squared is equal to 25. Okay? Now, how would you proceed to do that? You tell me.
Can you go ahead and square everything?
You see what? You may have said it right, I just didn't hear well. What'd you say?
He says square 3n plus 1.
Oh, okay. You certainly can. He's a hard worker, I can tell, okay? You can do math, okay? But for those of us who are a little lazier than that, what might we see to do? This is obviously a perfect square. That's obviously a perfect square. So guess what we could do? Just take the square root of both sides. And what will that give us? 3n plus 1 is equal to? Plus or minus 5. Very good. Remember, anytime you take square root of both sides, you got to do a plus or minus, okay? So what do we have? We actually have 2 equations, don't we? We have 3n plus 1 is equal to 5, or 3n plus 1 is equal to negative 5. Okay? What would the first one do? What would you do first? Subtract. No, subtract. We're now solving for n. Okay? All right. Yeah, so first subtract 1 from both sides. Okay? And that gives us 3n is equal to 4. Divide by 3. And that gives you n is equal to 4/3. Okay, on the other one, what do we do? Subtract 1 from both sides, and that gives us 3n is equal to what? Negative 6. And divide by 3, and you get n is equal to negative 2. All right, do we have time? I think we do. All right, this is going to be fun, isn't it? Let's do 4/3 for n. 3 times 4/3 is what? 3 times 4/3. 12/3, which is workers in here. The easier way to do that was to divide the 3 into 3, and you get 1, and you get 4 that way, rather than multiplying and then dividing. Divide, then multiply. But that's all right. 4 plus 1 is 5 squared is 25. There, we got it. How about if you put a negative 2 in here? 3 times negative 2 is negative, second, 6 plus 1 is negative 5 squared is 25. Both of those work. Way to go. So there we solved it. Doing it the other way was perfectly legal in most states, but it would have been a lot more work. Okay. So that was example 6. Okay. Now, we're going to start next time at example 7. Okay. Let me give you a few homework exercises in this one. Oops, wait on just a second. Okay. Few homework exercises. 6.2. Any of the odds 1 through 19. Well, wait. Let me break these down. Any of the odds 1 through any of the odds 1 through 19. Forget about 21 through 25 now. I mean, you can work them. They're fun to work, but if you don't want to, you don't have to. Then 27. 45. 47. No, don't be adding any. 51. I give you odds so you can check them in the back. Okay? And I think that's all you need to do there. Okay? And we can go from there. The others, I tried to skip those that use I's and radicals because we haven't done those yet really. So hopefully you can just do those. Good deal. Any questions? Have a good weekend. We will see you on Monday.